Thanks, folks. Now, I was going to say that we've got like 25 minutes. I've got more content than that, obviously. And so if people have questions, I'm totally happy to go off script. So please, speak up early and often. Just this, the people I'm representing here, Andrea Amy, myself, Jody Garnett, and Martin Davis. These are some of the leads behind the technologies we're going to be talking about today. My intro was already covered. I volunteer a little bit with the Open Source Geospatial Foundation, the hosts of this event, and also the Eclipse Foundation, which is another software, another software foundation that's been instrumental, especially productive in working with some of these larger organizations like Oracle and IBM and so forth. So, and then I also just want to take a moment to acknowledge the wonderful work of my employer. GeoCAD is a product company which gives me sustained funding to be a good custodian of the technologies we're talking about today. I can't say enough about how nice it is working with your own, but also how nice it is kind of not doing consulting work where you show up and then the project ends and you vanish. Just the ability to show up and help support these technologies day in and day out is a great service to our customers, and it also is a really great service, allows us to be a good software stewards. Okay, GeoTools 34. GeoTools is the open source Java library that does GIS stuff. Basically, GeoServer is very well known as an end-user facing application, but anytime we get something working in GeoServer, we actually go and stuff it into the GeoTools library so we can reach a wider audience. So this is the library that does all the image formatting support, it does all the referencing, it does a lot of the rendering and so on. You might have seen a little t-shirt with, all GIS software is like GDAL and trenchcoat. That's not true. We've got an entirely separate Java software stack, and I'm going to be talking about the components that make that up today. So we are standards compliant for a reason. GeoTools 1 was a complete and utter success. So successful that the users asked questions, and they spent so much time answering the questions they couldn't work on the software. So the only answer was to fire the users. And so thus GeoTools 2 was born, and we built it around OGC standards, in part so we could tell the users, go away, read the documentation, read the standard. And then also it solved a fundamental problem of developers arguing about how to name stuff. So rather than argue back and forth, we could go and read the standard and say, yes, that is called a feature, or that is called a grid coverage, I don't know why either. GeoTools is one of the kind of oldest GIS projects around. It started way back in the 90s, I think like 95 or something, and we've marched through different versions of Java, GeoTools 1, GeoServer, GeoTools 2, and then finally we renamed it as GeoTools in the 2010s. And I'm just going to briefly call out some work that the OSGeo Foundation funded. So at one point we donated all our interfaces to the OGC, and called it org OpenGIS, and we made some common Java interfaces to do collaboration with projects. That wasn't successful. It was a hard learning experience for us that to have collaboration between project teams, everybody needs funding at the same time. So flash forward like 15 years later, they're like, hey, org OpenGIS is trademarked. You have to stop using that. And so OSGeo and OSGeo board helped bring together some funding, about 20,000, for us to take those packages and rename them and get them out of our code base. So it's a bit of a shame that we put ourselves out there and the activity was met with failure, and then we bore a financial cost to clean up the mess. So as a result, GeoTools has now changed. It's got an org GeoTools API rather than org OpenGIS package. We led a successful cross-project activity to make this change, and it actually gave us a lot of confidence that we could really trust our test cases and make a fundamental change and push a change out across the Java technology stack. We also have something sad to report, a security vulnerability. So this was a serious security vulnerability that occurred in the last year. It had to do with like little XPath expressions, and this was something that you could actually exercise from GeoServer WFS or GeoNetwork. So this is like a full alarm security vulnerability. We went through our new process of registering what's called a CVE and publishing it out so it would show up in software scans and people would know to update. So this was a test, a real-world test of our new security policies. So just, if you're running an older version of GeoTools, please update. Yeah, and here's another one. So this one had to do with like XML parsing, and we introduced an API change so you could pass what's called an entity resolver in. The big thing we're working on right now is transitioning from the Java Advanced Imaging Library to this new ImageN project, which I'll talk about in a little bit. But I just wanted to say that we've been successful in that change. And so GeoTools 34.0 is the first public release with a new image raster processing engine. As a consequence, we now are Java 17 as a minimum. Okay. Also, some other fun changes as we went to Java 17 as a minimum. It's a little bit startling now that Oracle is no longer in control. The Java language is evolving again. And so they've got a few little creature comforts. We now change from using little arrays to using ... They now do little literal strings and optionals. So just we've been keeping the code base up to date as the Java language evolves. Another interesting change has to do with the package system Maven. They've long had a concept of a bill of materials, so you could import all of GeoTools in one go, and that's been used by other projects like Spring and so forth, and we've been able to adopt that. So we now have a GeoTools bill of materials where you can import, depend on all of GeoTools in one go, and then also all of our kind of dependencies. So you end up with the same version of like the Postgres driver that we test with. Okay, that's it for GeoTools. I'm going to pause. Any questions on GeoTools? Okay. I will keep going to JTS Topology Suite. So who here is familiar with JTS Topology Suite? A couple people. Who here uses, who here uses QGIS, for example? So QGIS depends on a geometry library called GEOS, which is a port of JTS. All of the geometry and spatial interactions all come down to this one geometry library, and it's ported to different environments. So this is all the work of Martin Davis, who was acknowledged with the Saul Katz Award a few years back, because this is absolutely the bedrock of the FOSS4G experience. He works on a number of different open source projects, JTS, GEOS, PostGIS, and so on. And he loves math and geometry. And I'm really glad he does, because he's really good at the math. So this is a library for working with 2D geometries. And JTS is used everywhere. So it's used directly in a whole bunch of Java projects. It's used indirectly in a whole bunch of GEOS projects. And there's also a port of it to JavaScript. So if you use any of those technologies, you're resting on the shoulders of this project. The fundamental building blocks is relationships. Just like our connections here at FOSS4G, we need to be able to know how two geometries interact. And the math behind that is called point set theory. So this is the math behind whether something's inside or outside or on the boundary between two geometries. And that's done using something called the Dimensionally Extended 9 Intersectional Model, or DIM9. I won't bore you with that. It turns the relationship into a little string, which us developers like because we can do pattern matching on it. The interesting one is the relate op was the first kind of real algorithm in JTS written in 2000, and it was ported to GEOS when GEOS started in 2003, and a speed up was made for it called prepare geometry, where it would remember the graph of one geometry and use it to compare against thousands of others. And it's the foundation of many geospatial systems, GeoTools, GeoServer, PostGIS, QGIS, and so on. It's executed billions of times a day across the world. So this is very important. And what's really nice, well, I was just going to say, Relate builds up a little graph of the full topology between how two things interact. And yeah, so it's used for spatial indexing, point and polygon tests, doing noding and so forth. But we have a fundamental problem here. It evaluates for every node in that little graph. And so if you don't use all of that information, it's doing extra work. And for something that's executed billions of times a day, it would be really nice to optimize. So, yeah. Just here's some of the optimizations we'd like to do. And Martin's been able to accomplish that with the relate-ng function. So this is a new change that's available in JTS, and it's also available in GEOS in 2024. And this should result in considerable, considerably lower the amount of CPU cycles burned, lower the environmental footprint of all of our GIS industry. So it's amazing this one project has so much reach. So yeah, uses the short circuits. It only calculates what needed for the relationship it's trying to test. Here's some examples of the performance gains. You can see it's kind of an order of magnitude there for the different options. And here's another one. And the other interesting change is you've got the idea of this polygonal coverages. So features that seamlessly cover a surface, there's no boundaries between them. And it can be a challenge editing a shared boundary. And so there's this idea of doing coverage validation and coverage cleaning. So this is also new functionality that's coming out in JTS. And coverage union and coverage simplification. So he's had some budget here to go through the idea of where the features touch and optimize. So there's lots of ideas now that the infrastructure has been built for relate-ng. We do have the option to start doing curves and other things. We simulated that in GeoTools, but we could actually start doing it natively in JTS if volunteers and people are interested. So just looking ahead, I will be trying to make a new release of JTS on the Community Day on Saturday. So for people that are interested, please show up and help out. I have to argue with Maven Central and how to deploy things again, but it should be good. How am I for time? Okay, I'm probably talking too fast. Does anyone have any questions on JTS? Yep.
Do you mind if I give you the microphone just for the recording? Thank you. Speak louder.
Okay, so basically now the library is 2D. Any plans for a 3D possibility?
So this is part of the work that was done.
Okay. So the answer is Martin is not interested. But the library, now that the infrastructure is done for relate-ng, has the flexibility to accomplish that. Ideally, we would love to do a JTS2 where things are represented as interfaces, but he's accomplished almost the same thing by doing like a double dispatch, so you look at the two geometries and can look up which relate operator to do. So if one of the operators happened to be a curve and one happened to be straight lines, you could look up something appropriate. It's interesting for 3D, you don't do a dim9 matrix, you do like a dim4 matrix, and there's only a few libraries in the world that do that, written in C or something. So the math for 3D is a little bit harder. Video games and other things do optimizations and assumptions that Martin, being a math geek, doesn't necessarily want to take on. So the answer is yes from an architecture point of view, and oh my god, from a math point of view. Yep. Okay, now to ImageN. So the original Java Advanced Imaging Library offers like a pure Java solution, so no C++ code, for doing image processing. And what's interesting, it does a tiling computational model. The buzzword for that is like on-demand processing or something. So it can work with huge amounts of data, pulling it in a tile at a time, processing it, generating a little bit of output. So you can set up this processing chain, and only pull the data through that you need for your answer. This is a little bit like with SQL, where you build up a query plan and it only goes through and grabs enough rows to answer your question. It's kind of like a lazy execution model. Deferred execution model, if I see my slides. It's also really nice in that it can be threaded, and importantly for us, it's extensible. So this image processing engine, we've been able to go in and customize without without changing out. We can change out the components without having access to all of the source code. So yeah, border extension, image wrapping, graphics 2D drawing, regions of interest. We've been able to do all kinds of stuff with this over the years. Problem is, it's really old. And when I want to say really old, here's what else was cool in 2009. Okay, so yeah, I'm not going to start singing, so you're safe there. We also took this library and we've extended it specifically to work with geospatial data, and that's the JAI extension project. And we've added features like region of interest and no data support that are really of value to our community and raster data and so forth. But that original engine was amazingly well engineered. Here's like just an overview of what kind of functionality it had and what kind of functionality we added. So we were able to add some optimizations using better caching technology and so on. And then we built a bunch of downstream stuff called JAI tools for doing contours and range lookups and vectorization and zonal stats. And then a really fun one is called GIFL, which is a little domain-specific raster calculator. So you could do like vegetation index calculations pixel by pixel on the fly. So lots of fun stuff. There's a problem though. It's not open source. We couldn't just pick it up and improve it. It was one of these source available licenses. So the source was given out to researchers, but they couldn't do anything with it. They could only look at it. So that's a shame. It was originally intended to be part of Java. So it was included in Java, and when Sun Microsystems was bought by Oracle, and Oracle eventually created OpenJDK, they open sourced all of Java except for this part. Why? Because of codecs, because of money. So in here are some video codecs which might have some patents associated with them, and so the lawyers felt they should hold on to that one a little bit tighter. So two problems: the binary license was not open source, and the project was largely abandoned by Oracle. Oracle hasn't always been the best custodian of technologies, you might have noticed. But wait, we noticed that Oracle, with a little bit of threats, had just donated the Java Enterprise Edition to the Eclipse Foundation. They had a little bit of help with Red Hat and IBM leaning on them, so I thought, hey, I wonder if we could ask Oracle to donate this to us. Even if they just donated the interfaces to us, it would save us a lot of time. Yeah, and so we contacted them through our friends at the Eclipse Foundation, and the answer was maybe. And yeah, so we noticed they were using it still inside their Oracle database product. So yeah, in 2019, I was working with a startup called Boundless, and we started putting together a budget on how to replace this. And we were coming up with $150,000 budget or so to make a project called the Raster Processing Engine. And we actually formed that with the Eclipse Foundation Working Group. But before we started working in earnest, we asked Oracle one last time, and the result was they donated the code base to us. So all of a sudden our project effort went down by like a third. So it was just a really, really nice timing. So in the initial 2019 meeting, they donated us the code base, they donated us the user manual, but they didn't donate us the test cases. So we had a code base and we had no idea if it was safe to use. And yeah, and so we've had the code base since 2019, and we haven't really had enough budget or effort to bring it home. So we formed the ImageN project in 2019 using that heart of the original JAI code base and the JAI documentation. We didn't get all the build engines and test cases and so on. Yeah, and so this project has just been sitting here waiting for funding since 2019. So here's what happened in 2024. We've gotten some funding. I'll talk about it in a moment, but it is going to work in Java 11, so it's a pure Java implementation. It does work with the Java module system, and yeah, so so JAI will work in 11. It has some conflicts with the module system. The problem is when we go to Java 17, which we have to do for the latest Spring updates and Java Enterprise Edition, Java is starting to lock down use of the internal JavaX namespace. So we can no longer run it because it still uses this JavaX namespace. So as a result, GeoTools and GeoServer and everybody, we have to go to ImageN now. So that's terrifying. ImageN better work. As part of the big crowdfunding effort for GeoServer 3 that I'll be talking about later in this conference, we've actually got enough budget to bring this home. So we had the idea, now that this is urgent, we combined forces with that JAI extension project because it had test cases. So by putting together two projects, we were able to get one good one. And yeah, so just a successful crowdfunding result, and we've been working on this as part of Milestone 1. So just a moment to thank the GeoServer 3 sponsors. We put out the call for funding last September, and by June, these organizations and others were able to meet that call for funding. And ImageN is one of the key technical risks being addressed. So yeah, can we do the actual swap? Can we take out JAI and put in ImageN? So we started in May. We had a little online code sprint, and we combined the JAI and JAI extension code bases. And yeah, we were able to get a little bit working. And we were able to do a little automated script to try and update all the downstream projects, GeoTools and GeoServer and so on. And we also made a logo. It's a very nice logo. You can see like the iris of the camera lens around the circle there. And then at the FOSS4G Europe code sprint, we were able to factor out a few of the legacy operators out of the way. And we were able to get kind of the main branches building with very minimal QA checks. And then finally, in August and September, we were able to bring it home. So specifically, we wanted to compare the original operators with the new ones from JAI AXT to see that they made the same output. So we introduced a bunch of reference images. Here's what this one produced. Does the other one match? We also found a few operators that were in use and we didn't know about. And yeah, so we were able to get this and actually make a version 090 release and release it to the public as part of GeoTools 34.0. So ImageN is now working. It's in wide deployment. It's not version 1 yet because we want to clean up the docs and add a bit more test coverage and so on. But we are amazingly happy with this result. Thank you.